Okay, so this is where we left off from our last video. So the part is complete, and one thing I would like to go over straight away is Bumble in the comment section of the last video mentioned how we can change the feed rates in the corner on toolpaths like floor wall, like we did here. Wall floor, sorry. So I just want to run over that with you and show what he showed us. So in the wall floor profiling, and this is other toolpaths as well, it's not just this one. So you have this adjust feed rate here. So normally it's set to none, and it obviously will do no adjusting. So you can also adjust the feed rate on all arcs. So in this circumstance, it will also adjust the feed rate on the approach arcs as well, which isn't ideal, but you can see how it can really help in other situations. So the maximum compensation factor, that will be, if you leave this at 1, you can think of it as like 100%, because 1 would be, it will stay at 1,000 feeds. So here you can see our feed rate is 1,000. So on here you can see it will stay at 1,000 the whole way around. And you can see here we have a minimum compensation factor of 0.5, which is, let's say, 50%. So I'm basically saying in the corners you can go to 50%, which would be 500, but never go less than that, and never go more than 1,000. So you can't visualize it here, which is not great. So if we go into options, and then you have a few like display options in here. If we go into the edit display, you'll see you have this feed rates button here. So normally this is turned off, I've turned it on. So if you have this turned on, what happens when we generate this, you'll see all of the feed rates. So you can see on the engage, because it's an arc, it's 50%. And then we get up to 1,000, 50% here, 1,000, 50%, so on and so forth. So this is a good way to make sure that your corners are going to have a really nice finish. So yeah, thank you for that, Bumble. Okay, let's carry on. So this is where I would normally, go over the toolpaths, make sure I'm really happy with everything, make sure there's no improvements that I'd like to make. So let's quickly do that now. So I mean, straight away, this is our roughing toolpath. I'm not sure there's much to improve in here, but one thing that I have noticed is this arc, engage here. It's pointless. It's engaging on the outside of material. There's no need for this 3mm height here, so I'm going to get rid of that. Take it down to 0. Generate that. Now you can see we're going to wrap it all the way down to the bottom and start our cut. Otherwise it would have wrapped it down to 3mm and then feeded down that 3mm and carried on. This way it's just more efficient. That's one change that I've made straight away. And you can see now my other roughing has out generated itself. It's, you can see here that the IPW is out of date. And that's because the roughing operations after your initial one uses the stock from the last. So it thinks that something has changed. Although we know the toolpath hasn't actually changed, we've regenerated it and we have changed something slightly. We know the stock's not going to change, but here it's just letting you know that you need to regenerate this toolpath to make sure you've got an up-to-date stock. So there we go. But then this one, I don't see much improvement there. That's a nice toolpath. Adaptive roughing, so it looks pretty good to me. We need this height here because where it's helical and engaging, this is 1mm above the part and it's finished to 0.5 mm. So it's got 0.5 mm of engage just to let the helix start, and then it's going to start cutting into material. So it's going to be, you can't really get rid of this in this case. Planar mills, I'm happy with these, I think. Don't think there's much to change there. We've just gone over that. So another good place to see that feed little tip was boring and remin, because if you remember we came out at 300% of the cut. So let's just quickly check. So we've got the feed rates turned on. Now when we generate, we can see we are cutting at 250 feed and retracting at 750. So that's all good. So yeah, this is finished, I would say, this program now. So let's just make sure we save the part. And now what we need is we need some stock. We need a stock for our second operation. So as always with NX, there's multiple ways to do this, but my preferred way is I like to click on the top level program, so it's going to look at everything, and I'm going to go to the verify toolpath. So replay is just your literal toolpath. It doesn't show any stock being removed or anything like that. So if I just play this, you can see the tools going around, nothing too crazy. In 3D dynamic, in here you'll be able to see the toolpath removing the material, so that's the only difference. So we want to create the stock, and the best way to do this is using the 3D dynamic and suppressing the animation, and I just run it through like this. Okay, so here we go. It's just a good visual as well. You can see that all of the faces are finished. You know, you're getting this weird looking finish because the faces are perfectly on each other, which is a good sign. Yep, so that all looks good to me. And now we need to create this IPW. So here we're going to create it. That's just going to save it to the screen. And now if we go to our part navigator in the non-timestamp geometry, we're going to see this facet body. I'm going to rename this to Op10 final stock. So this is our resulting stock from Op10. So maybe resulting stock actually makes more sense. Op10 resulting stock. So this is what's left after Op10 has finished. So we have that. We have everything else. So the next thing that I want to show you is we want to create. This isn't like, you don't need to do this, but I do this just as good housekeeping, because you're going to have to flip this part over for the second side. So you'd either have to flip, you can either flip all the parts together, or I like to bond the two. So I'm going to use a constraint. So we're going to have to go into modeling for this. So you can either use M or go to here. You can either go modeling or just M. I'm just going to use M. And now we want to create a constraint. So you can see here I have all of these constraint options available to me. These are, we're going to definitely get into them, but at a later date when we start using vices and stuff like that, it's going to become quite important. But for this, all you need to know is, oh, look at that, it's created an IPW for all of our, created an IPW for every op, which is quite interesting. I don't want them, so I'm just going to delete them. Okay, so yes, and to create a constraint, you have to do it against this facet body and the part. So that is the design master part, not the linked body. So I'm going to turn off the linked body for this. I'm going to turn on my part. And now I'm going to create this one, which is called a bond. And a bond basically like sticks two objects together. So when I flip over my part, my stock's going to go with it. I'm going to create a bond. And that is not a bond. This one, bond. And I want to bond my part. And yeah, I'm going to need, you can't bond an IPW, it has to be a component. So let's create it as a component first then. So new component, and let's just call this Op10 resulting stock. I'm just going to save it from absolute origin. So this is the name it should get, but I'm not sure how this is going to react. Your reference set, don't worry about that for now. Layer options, again, don't worry about that for now. Just leave it as original, because we're not really using layers in this course, because I like to use feature groups mainly. And then component origin from absolute, so it's going to save it from our absolute datum, which is pretty good practice, but you could also save it from a WCS. Let's say you saved it from a WCS and you just sort of had a WCS somewhere down here at the bottom. When you bring this part into a different part file, depending on where your WCS is in that part file, it'll be relative to that WCS. Or I just prefer to use absolute because then it's the same for every part file. Okay, and if you have delete original objects, it's going to get rid of this facet body. It's just going to delete it and turn it into a part, basically. There's nothing else in there, so let's see what happens here. We still have it on the screen. And now when we go to our... So that's strange. So in our... This might act a little bit weird, but in our assembly navigator, it's saved it as model 3. When I highlight it, it actually shows it as the correct part number, which is strange. You'll see, look when I'm highlighting it, it's saying op 10 resulting stock. But then here it's not got that, it just says model 3. We open it, it says model 3 too. Let's open that and let's just see where that is saving to. So I'm going to save it. I'm going to save as. I'm going to save it in this file here. So you can see I've got all of these parts in here, so I'm just going to delete them because I don't want them. So this is because I was playing with it before and I had them all saved as component. So I want it to save in that folder there. So let's save as this file separately. You can see I've got 2 windows open now, so this is this model 3 file here. I'm going to save as. In here, I'm going to call it op10 resulting stock. Okay to that. So now it's renamed it to op10 resulting stock. You might not get that on your computers. I'm not sure why I got that. That was strange. I've never seen that before. But now it's the correct name. Yeah, strange. So now I actually have components. So I have my part, and in here I have my stock. So now you can see we've got an assembly going on in this file. So now we can use the bond feature. And I'm going to bond the part. So you see sometimes it can be difficult to select it. If you just stay there until these 3 dots appear and then click, now you have options. I'm going to select the part and then I'm going to select the IPW. So now I have a bond going on between them two. And you can see that in here. So this is our constraint navigator. We've not really looked into here much yet. And to be honest, you don't really have to much when you're a CAM programmer. This is... yeah, but we can see this is where the constraint gets saved to. So now we are going to kick off our part file for op20. So let's start that. Best way to do it that I find is I'm just going to save as this session. So file, save as. I'm going to create a new folder in here called op20. And then I'm going to use the same naming format, but it's going to be part 1 op20 now. Save that. So now you can see we're now in the new session, part 1 op20. So you can see currently we need to flip this part over, but it needs to be this way. Okay, so let's do that. So the best way to do that would be make sure we're in modeling. And we want to be in assemblies. So why we did the bond before is because this linked body here, this is a link of the part, and no matter where that part is, the link will follow it because it's associative. So what you'll see in the settings is this associativity of this main link. It means whatever happens to the main part also happens to this link. If I went and started deleting the holes out of the main part, it would delete out of the link. If you untick the associativity, it becomes a dumb body. The link has been taken, but at that moment in time. So you start changing it, it's not going to be good. So the great thing about the link and the great thing about our stock, we don't actually need this anymore because this was from our first stock. So we'll clean that up afterwards. So we want to move this part and flip it 180 degrees through the Y plane. So let's go and do that now. So make sure we're in the modeling tab. Want to go to assemblies. Now we're going to move component. So this part, anything that you see in the assembly tree is a component, and anything you see in here is like more like dumb bodies. So you have to do move object and not move component. So let's move our component. We want to move our main, this one. So you can see here you got lots of different options. Dynamic just allows you to move things on the fly. So you can see like we've got this window that's just appeared. So now I can start pulling this around. That is what we want to do. We just want to move it exactly how we did it there. But you've also got many of other options that we will get into at a later date. So we've just flipped it 180 degrees through the Y plane. Now we're going to OK that. And now you can see everything's gone with it. So our stock's gone with it. And our link body has also gone with it. Okay. Now we're ready to tidy up this file. So we need these two parts because this is going to become our stock for the next stop. That constraint is fine. We don't need this anymore because that was our stock from the first stop. So let's clean that out. Okay, now let's go to the CAM session. So Control Alt and M, or you can just go into the manufacturing window up here and select it there. So now you can see everything's gone ungenerated, and that's because we've moved the part. So let's just flick through this session. So the first thing is we need to change the main program name. This now wants to be up 20. Let's go into our tools. So we don't, ideally I don't delete the tools and the operations till the end because you never know if you need to like reuse any of them. So what I like to do is I'll just I'll drag everything into unused. So now I've got my main program here and I've got all of these toolpaths in the unused geometry here. So I might use them again. That's good to leave them there as well as the tools here. But our geometry's changed now, hasn't it? So we need to go and update that. So our MCS, you can see, is now slightly too far down because it's looking, you know, last time it was at the bottom of the stock. Now we want it at the bottom of the part. So let's go and move that up. The best way to do this is probably to create a WCS first. So a WCS is this one here. So this is one I can just move around and put it into different positions and change it, whereas our machine datum never really moves and you can't really use it for datums or anything like that. So let's move our WCS first. Okay. And we want this in the middle of the part. So let's do move on a WCS origin. And now we want to click probably, it looks like there's a few options here and we could do, a good one here would be between 2 points. So we want this to be a point on this face. So we can do between 2 points here. Obviously you've got lots of other options, but between 2 points should work quite nice. And if we select this point and this point, it will give us a point in the middle of our part like that. And let's see, so that looks pretty good. And now we can just do some measuring. So one thing that I like to use, if you just type in this corner, point information, this one, it takes the point information from your WCS absolute like position, or you can change it to be absolute, which this position here is. So I'm going to leave it so it makes sure it's on WCS, and I'm just going to select 2 corners just to make sure I am perfectly in the middle. So this face, that listing window is a bit big. Let's just reduce that down a bit. So that point, and make sure we get the opposite one, this point here. So I just like to make sure that these figures tally up. So I've got X107. Sorry, this is your absolute X up at the top, and your bottom one is your WCS. So 47, 47 and a half, 24 and a half, 24 and a half, 0, 0. So I know I'm bang on in the middle. Okay. So now this is just a datum just floating now. I like to save it. If you do a save WCS, look at this, I get a nice little saved WCS that stays on the screen, and I can use this now for my machine datum. So now if I go into my machine datum and I go to inferred, so inferred, it will try to figure out what the best option it wants for you. This is pretty good most of the time. So now if I just hover this, I can see it's got that coordinate system there for me. I can just OK that. Okay, cool. So the next little tip that we didn't do on the last one that we should do on this one is we can set the clearance option in this one here. So how we changed it to 5 mil last time in the automatic plane, we could do that here if we like. So let's just change that to 5 mil there. Okay, so now all of the toolpaths that live under the MCS will inherit that 5 mil plane. So our workpiece has changed. So now the part, you can see it actually still, the part is still there and it's still fine. So that's fine, we don't need to touch the part. But now our blank, you can see it's disappeared, and that's because we deleted it out of the tree. So now we just want to reselect our IPW. So you can see it's on solid body here. I'm just going to change it to facet body as our selection filter. Now I can select that facet body there. Okay. Our holes, they'll stay the same, and we'll probably need them for when we come to the burr, the edges. And our method group won't change. So now we're at the part where we're ready to start programming this second stage. This file is ready to go. So let's do that in the next video.